Greetings, statistics scholars, and welcome to the second video in our series from chapter number 1. In this video, we're going to be taking a look at the subject of sampling from a population. Suppose you're interested in answering the following question. What proportion of all U.S. retirees spend a day of recreation at a beach beside an ocean at least once per year? Now here you're seeking information about the set of all living American retirees. We would say here that U.S. retirees is the population that you are studying. How will you go about answering this question? How will you obtain the information you need? As we'll see in this video, the manner in which you do so has very important implications. Today in this video, we're going to be talking about sampling. Now, usually, a population of interest, such as all U.S. retirees, is typically so large that it is difficult and expensive to obtain data from every individual case in the population. In statistical terms, a survey that includes data from every single case in a population is known as a census. But taking a census is typically not feasible. So because of this, researchers usually resort to selecting a subset of individuals from the population, and they take data from just that smaller group. We call such a subset of individuals a sample. And the process of deciding who will be included in the sample and collecting the data from that select group is known as sampling. In this video, we're going to take a look at 4 different possible strategies that could hypothetically be used to help answer that earlier question about retirees and the beach. In doing so, here's a big picture to keep in mind, and this is a diagram from section 1.2 of your text. We start with a big population, that of all U.S. retirees. And we're going to use some approach to take a sample or a smaller group from that bigger population. Now, what we hope to be able to do is something called statistical inference. We hope to take the data from our smaller sample, and we want to be able to use that data to say something about the population at large. In other words, we'd like to extrapolate or we'd like to generalize from our sample data to say something meaningful about the big population. Now, as we look at 4 different approaches in the upcoming slides, what I'd like for you to be doing is be thinking as you hear and read each approach about how reliable it will be to generalize from the sample to the larger population. So let's plunge in and take a look at 4 approaches briefly here. The first approach is one that's going to be used by a woman named Lakeisha. She's got a friend who works for a website, and she asks her friend at activeseniors.com to post a poll to this internet website, asking the seniors the question. And she finds out that over the course of a month, her friend reports to her that 180 of the 300 responses were favorable. 60% of those answering said yes, they did spend a day of recreation at an ocean beach at least once per year. Okay, that's one way of doing it, using an internet poll. Well, suppose we do things differently. Suppose there's a gentleman named Lawrence, and he lives near Omaha, Nebraska, and he works with senior services. And he has a computer program there that will randomly select people on that roster of retirees. He asks his computer program to randomly select 200 of the people on the roster. He calls them and asks them the question and finds out that of those retirees from the Omaha area who were randomly selected, 36 out of the 200, or 18%, said that they had spent a day in an ocean beach at least once a year. All right, so that could be another approach. Let's consider two other approaches to round things out. A woman named Libby contacts the American Association of Retired Persons, and at her request, they print out the email addresses of every single individual who has joined their organization of retired persons during the last year. And they put the names or they put those email addresses in a bowl, and 180 of them are pulled out blindly from the bowl. And those retirees are contacted. And it's found that of those 180, 45 of them, or 25%, say that they had visited an ocean beach once per year. As a final approach, a man named Linus lives in Atlantic City, New Jersey. And he goes to the downtown area late in the evening at 7 p.m., stands outside of a popular restaurant, and as people come out, he asks them if they're retired, and if so, if they have been to an ocean beach at least once during the year. He finds, as a result of his questioning, that 340 out of the 400, or 85%, has spent a day or more at an ocean beach, the highest proportion of any of the researchers. So now we have four different estimates for the proportion of US retirees who spend at least one day at the beach. From Lakeisha, we had a proportion of 60% that had come from the internet poll. From Lawrence, we had a mere 18% that came from the result of making phone calls to the retirees in the Omaha, Nebraska area. From the Libby's approach, she had to end up with a proportion of 25% of those that she emailed from the AARP list. And the very largest proportion came from Linus, who found that 85% of the retirees that he talked to in front of that restaurant in Atlantic City said that they had been to a beach at least once per year. Now, obviously, those four results can't all be accurate. We have four wildly different, wildly varying results. Which of these is most trustworthy, and which one of these do we think is probably most likely to be a good estimate for the proportion of those, of all of the retirees in the US who have been to a beach at least once per year? Let's think about those sampling methods one by one, and we'll observe some important things about them. Perhaps you've already decided which one that you think is most reliable. Let's take a look at some statistical terms. First of all, as we think about Lakeisha's sampling method, we must realize, first of all, with her web-based approach, that only retirees with internet access could have participated in this survey. Moreover, it isn't enough just to have internet access. You also have to be aware of the website activeseniors.com. So that means that any retiree who doesn't have internet access or any retiree who is unaware of the website is simply going to be left out and will not be able to participate as part of the sample. Because of that, we say that Lakeisha's method suffers from what we call sampling bias. Sampling bias occurs whenever the method of selecting the sample causes the sample to differ from the population in a relevant way. We had set out seeking to get information about all US retirees. Clearly, this sample doesn't reflect all retirees. It only reflects those retirees who have internet access and those who are aware of that particular website. So because of that, we would say that there is sampling bias in Lakeisha's method. And we probably ought not to use it to generalize to US retirees as a whole because of this. And what about Lawrence? Interestingly, Lawrence relied on a disinterested computer program to randomly choose which 200 individuals living near Omaha would be called and asked the question. Now, Lawrence was using an important technique known as simple random sampling. He was using this technique, though, for a more specific population than the one that we initially listed, remembering that Lawrence's list only included local Omaha area seniors. Now, because Lawrence used the computer program to choose which 200 of the Omaha area seniors would be included, it is true that every unit in the population of Omaha area retirees had equal chances of being selected. But we can't generalize to a bigger population that's larger than that. That percentage of 18% that Lawrence ended up with, that would be a reasonably good uh, number to use for the proportion of Omaha area retirees who have been to a beach at least once per year because of the simple random sampling technique that was used. But we probably oughtn't to use it as a proportion for all retirees all across America because Lawrence was only sampling from those seniors, those retirees in the Omaha area. Now that we've thought a little bit about the first two, I'd like to ask you to pause for a minute and think about Libby's approach. She was the one that had the names chosen from the bowl, those email addresses obtained from the AARP. And think about Linus, who stood outside that restaurant in Atlantic City, New Jersey at night. Which of these two approaches, if either, used simple random sampling? Which of them may have had sampling bias? Think about that for a moment. And as we close out here, we'll try to decide which of the four techniques as a whole we think might be the best for giving us an estimate about the proportion of all US retirees who have been to the beach once per year. Do you have your thoughts about Libby and Linus? Well, if you said that Libby was using simple random sampling, you're right. Her research team drew those email addresses from a hat. Every one of those email addresses of the folks who had joined the AARP were equally likely to have been chosen and received the email. So that means that these results are reliably generalizable because of the simple random sampling. Moreover, the AARP is a national organization. We didn't just have retirees from the Omaha area or from the New Jersey area or the Florida area. There are going to be people in the AARP from all over the country. So as a result of using simple random sampling with a group of email addresses that is nationwide, we may indeed be able to generalize Libby's results to the original population of interest. At the very least, we can say that we could reliably generalize them to those retirees who were involved with the AARP. But what about Linus? What did we think about his approach? Linus certainly did not use simple random sampling. Every retiree in the United States was not equally likely to be chosen by Linus's technique. His sampling method has bias. First of all, Atlantic City, which is where he was from, is the only place that could have a representative retiree participate. And Atlantic City is an oceanfront city, which is bound to elevate the proportion of those indicating that they'd been to the beach. Not only is his sample limited to just seniors from Atlantic City, but it's also going to be further limited to only those seniors who are able to go up and go out and get to dinner to be included in the survey. Any retiree who was homebound could not participate in Linus's survey. So there we have it. We have reviewed four different possible sampling techniques. In the process of doing that, we've learned about bias. We want to be on guard against methods that are going to make it so that some individuals from a population can't be included as part of a sample. If that's going to be the case, then we want to avoid those techniques that do not allow every individual from the population to potentially be included in the sample. We want to strive to use a technique like simple random sampling. The methods that were used by Lawrence and Libby, using computer programs to choose people at random, or using drawing names out of a hat to get email addresses at random, those approaches are going to give every individual from a particular group equal likelihood of being selected. And that is a very powerful technique. If we want to be able to do good statistical inference, to make generalizations about a larger population, using a simple random sampling approach like those used by Lawrence and Libby, in particular, the one that was used by Libby here, where she was taking information from retirees all across the country, is a good way to go to help to generate robust results that can be generalized.